Let's talk about how to come up with an equation when you're given different information about a sine wave. We have two new parent functions. They are, this one right here is sine. I know it's sine because it goes through the origin. If it's a parent function, the sine wave goes through the origin 0, 0. The cosine wave doesn't pass through the origin, but on the y-axis it hits its maximum, which is a y value of 1. So we've got sine and cos. With transformations, the parent functions can have this equation. So depending on, sine or cos, but we still have an a value, a k value, a d value, and a c value. So a, k, d, and c, those parameters are the same that they have been for our other functions. Example 1. Most of these parameters are pretty straightforward to find. So we're going to determine the a value, k value, and c value of the graph. D value is a little hard, so let's start with the easier ones. The parent function we're told is sine x. But if I had looked at this graph and said, what's the parent function? Was this originally sine or cosine? There is no way to tell. That's why you can usually choose between sine or cos, because you can make the equation an infinite number of ways using sine or cos. First, we want to find the c value. Whether we're talking about sine or cos as the parent function, it doesn't matter. Find the c value first. This is the equation of the axis, and it represents the vertical shift. So it's the horizontal line that you would draw that cuts through the wave, that kind of cuts it in half. So when you look at this one here, I'm going to try to draw a line on here. It looks like it would be, the line that would cut it in half, I think would go through -2. So the equation of that line that I just drew, it's a horizontal line, which means it's going to start with y equals. So its equation is y equals -2. That's the equation of the line. But when we're talking about it in terms of transformations, it's the c value. So the c value is, in this case, I'll put it right on top here, the c value is -2. That's the first step, is to find the c value. If you can't determine it visually, maybe you weren't given a picture of a graph, or these numbers are, it's very hard to tell where you think that line would go, all you need to do is take a maximum value, so that would be a 1, add on a minimum value, that would be a -5, so that would be 1 minus 5, and divide by 2. That will also give you the -2 value, so you can do that as well. So we've got a c value of -2. -2. That's the first step. Next thing we're going to do is find the amplitude. The amplitude is the positive distance. So amplitude is always positive. It's because it's a distance from the equation of the axis to a max or a min. So on this graph here, from a maximum to a minimum, this distance here, that's the amplitude. Or from the equation of the axis, which is the red line that I drew, to a minimum, that's also the amplitude. So we always say the amplitude is a positive value. So in this case, how many units is that? And again, if you can't look at it and you can't determine it visually, the amplitude is equal to, this time it's a max minus a min divided by 2. It's very similar to the c value, but except for subtraction. Or you can take a maximum, so our maximum occurs at a y value of 1. And we can subtract the c value. So that would be a 1 subtract a -2. Let me write this down for you. So if we were using the formula, a maximum is 1 minus the minimum is -5. So I change it to a +5 divided by 2. So you get 6 over 2. That's a 3. Or we could take a max value. The max value is a 1 subtract the c value. It's a -2. That's also going to give us a 3. So our amplitude is 3 units, not negative, just 3 units. So that's our amplitude. Third is to determine the k value. You'll need to determine the period to use this formula. So this is new. Well, this is the formula we've talked about. The k value is equal to 360 divided by the period. 360 because the parent function has a period of 360 degrees. So our sine wave has a period of 360 degrees, but we have to divide it by whatever the period is we have in the question to find the k value. So the period is take one maximum value and another maximum value and find the distance between them. That's your period. Or it's the distance between a minimum to another minimum. That's also the period. So we've got a maximum, put the point laser point around, we've got a maximum here and a maximum here. Now our units are hard to tell in this question because even though this is a 25, we're not counting by 5, so I should have picked maybe a better scale for you here. But the period is 90, which might be a little tough to tell in this example, but I think in your textbook it's clear. So the period is 90 units. So if our period is 90 units, I'm going to go down to my formula here. My k value is going to equal 360 over 90, and we always use fractions, not decimals. This doesn't work out to be a decimal anyway, but we get a k value 4. So our k value is equal to 4. And looking back up at the question, it said determine the a value, k value, c value. So we don't really have the a value, we have the amplitude, but the amplitude is also the a value, except the a value can be a negative. We'll talk about that in a minute. So amplitude and a value are almost exactly the same thing. So what's next? With transformations, erase this, sorry. With transformations, the parent functions can have this equation. So as I said before, sine or cos, it could be either. And then we just have to make sure to put a, k, d, and c in the right spot here. So the fourth thing we would do is the d value. But for this question, you're told there's no d value yet. There's no horizontal translation, meaning d, and that's important. Can you tell why? So why is d equal to 0? Why is there no transformation? So let's talk about the parent graph. The parent graph is sine x. Let me draw it on here in black. So the sine wave, remember, goes through the origin, comes up to a height of 1, and I'm looking at my scale here. I need to go 360 degrees. This does not go to 360 degrees, but let's just say we were going to 180. Let's do half of it. It would come up to a maximum of 1 at 180. That would be about here. So I'm going to just draw this really shallow. Nope, more shallow than that. And then it would be coming down, not that fast. 360, let's put 360 there. It would be coming down and crossing. Let me back that up. Sorry, start that over. Back at the origin, 0, 0, crossing at 180, having a height at, so at 90 would be about there. 90 and 1 is a maximum. So I'm going to hit my maximum at 90, cut through at 180. My minimum would be at 270 and back up. There's one cycle of the sine wave. Terrible drawing, but there's our sine wave. On the y-axis, the sine wave, the parent graph starts at the origin, 0, 0. So that is where my sine wave and my equation of the axis meet. The equation of the axis on the parent function is right here, right along the x-axis. It's c equals 0. So this is an important point right here, where my wave crosses the equation of the axis. So this has just been pushed down 2 units. This point of intersection with the y-axis and my wave has been pushed down 2 units. It's right here now. So if I took this red line and lifted it up so it was right on top of the x-axis, the whole graph would line up properly, except for the stretch and things. But it hasn't been pushed from side to side. So the d value is 0 because we haven't taken this point right here and moved it over, but we will in a future example. So if you're confused right now, just hang on. So let's write down our equation because we have all of our parameters here. F of x equals, our a value is a 3, I'll talk about the negative aspect later. We were using sine, so I know that it's sine. My k value, so I'm subbing into here. My k value is a 4, and then x minus d is a 0 for d, plus, and my c value is a -2. -2. Or you could write it as just 3 sine. Since there's nothing in the brackets, I could just put 4x minus 2, like that. So there's the equation of that wave. Example 2, determine an equation for the graph that does not involve a horizontal translation. Again, this one has no d value. So how could that be? How could there be no d value? When I look at this graph, it doesn't look like either of my parent functions. So my parent function for sine, as I said before, would be like this. This would be my parent function for, sine. So it doesn't look like that, meaning horizontally it looks like it's been shifted, right? It doesn't line up. I would have to take this point and move it way over here to line up. So it certainly looks like it has a shift. And my cosine wave, let me erase the red one here. The cosine wave on the y-axis starts at 1. It starts there and ends here. 180 is -1, cuts through at 90. So my cosine wave looks like that, and it doesn't line up with that either. The cosine wave has a maximum on the y-axis, but this one has a minimum on the y-axis. So let's discuss how there can be no horizontal translation when clearly it's not lining up the way it should. So first of all, draw cosec's onto the same grid. So let me just do a little bit, make that a little bit bigger here. All right, there's the parent function cosine in blue. So clearly we've got lots of transformations. This one, although it's a -1, it's going as low as the parent function is. It's way higher. So that means it's got a different amplitude. There are a lot of other changes. This black one is very wide. Look how long one cycle is compared to the blue one. I got several cycles in the same space. So there's lots of transformations. Let's put down the ones that we can see. First, remember I said from the example one is the C value. So where do you think that horizontal line would go? We want a horizontal line that's going to kind of cut this in half. If you can tell by looking at it, great, then you're going to draw it in. If not, remember the formula is you take a maximum value, that's a 7, add on a minimum, so add on a -1, so we've got 7 minus 1, that's 6, and then we divide that by 2, that's a 3. So our C value is going to be a 3. So I'm going to draw in a C value of 3. That's a really light color pen there, it's kind of yellow, but there's my equation of the axis. It's my C value there. I've got the equation of the line is actually y equals 3, but under our C value, let me make it a darker color so we can all see it. We get a C value of 3. And you have a couple of ways of doing that now. You can do it by visually looking at the graph. You can do it by using that max and min formula. So that's our C value is a 3. How about the amplitude? Okay, the amplitude, remember, is the distance, the positive distance from a maximum to the equation of the axis. That's why it's important to have the equation of the axis drawn on first. So this is the amplitude here. So how many units is that? Or you could go from the equation of the axis, to a minimum. That's also the amplitude. So the amplitude is 4 units. And again, if that's hard to tell by looking at it, you can always use one. There were 2 formulas on the other side of the page. One was maximum minus minimum divided by 2, or the other one is take a maximum, subtract the C value. So our amplitude is 4. What about our K value? K value, remember the formula for that? K value is equal to 360, because that's the parent function's period, divided by the period of the graph we're talking about, the blue one. So what's the period, sorry, not the blue one, the black one. What's the period of the black one? So we go from a minimum to minimum. Now, or you could do max to max, but I only have one max here, so I don't know where the other one is. So from this minimum to this minimum is how many units? And that's pretty clear to see because this minimum is at 0 and this minimum is at 720. So my period is going to be 720. So K is equal to 360 over 720. So my K value is 1/2, fraction not decimal. Key idea. If a graph's y-intercept is also the maximum value, which this one isn't, it's the minimum value, then using the cosine as the parent graph will not require a d value or a negative a value. We haven't talked about that yet. Okay, but what we have here in this graph in the black one is this scenario here. If a graph's y-intercept, here's the y-intercept right here, if the graph's y-intercept is also the minimum value, that's what we have, a minimum value on the y-intercept, then using the cosine graph with a negative a value reflection will eliminate the need for horizontal translation. Let me go over that again. We were not supposed to have we're not allowed to use a horizontal translation for this question. So the parent graph of cosine has a maximum right here. If all I wanted to write was the equation of y equals negative cos x, that would take the blue one and that would take every part of it and give it a vertical flip like this. This would be negative cos x. Okay, stop there. So that's negative cos x. When I have a negative value in front, it takes what was a maximum on my parent graph, the blue maximum, and turns it into a minimum. And that's very helpful when we don't have a horizontal translation or we don't want a horizontal translation. So if I took this blue graph and I flipped it down and then C value, and then I lifted it up 3, and then I gave it an amplitude of 4, and I do all these transformations, I would have the black graph. So if I took the blue graph, the parent cosine graph, and I did all these transformations, I would have the black graph. The only difference is I have my amplitude is a 4, but my A value is going to have to be a negative 4. Which takes this point right here that was a maximum on the parent graph and it flips it down to where I need it at a minimum. So my equation of the graph is going to be f of x equals, my a value is a negative 4 and I used cos. My k value is a 1/2. X minus d is 0. Plus c, and I'm just going to write that a little better here because I have a 0 for my d value, I don't need all those brackets. Negative 4 cos, you can put brackets around this part here if you want to, 1/2 x plus c. So the really important thing to get from this example is the graph that you're doing, if it has a maximum or a minimum on the y-axis, you should use cos for your equation. You get to choose, right? If it's just a determinate equation, I can use sine or cos. If I have a max or a min on the y-axis, it's really easy to use cos because the parent graph already has a max there. So if my graph had a max there as well, I wouldn't need a d value, I wouldn't need a negative a value if the graph I was doing also had a maximum on the y-axis. If it has a minimum on the y-axis, all I need to do is throw in a vertical reflection here. And that makes this equation, oh, I'll put a c there, sorry. Should have put a 3 there. Erase that. That should be a 3. Sorry. Okay, so that's a good example to watch again later when you start doing your homework. But let's do some more. Example 3. A sinusoidal function has an amplitude of 4 units, a period of 120 degrees, and a max at 0,9. Determine an equation. Start with a little sketch of what you know. Okay, we don't know too much here. Let's start. We've got a max at 0,9, so let's just say this is 9 there. We're going to have a maximum there. Put a blue dot. We've got a maximum there. It's got an amplitude of 4 units. Amplitude of 4 units. So if the amplitude is 4 units, amplitude is 4. Remember our formulas from before. Our C value is equal to a maximum, subtract the amplitude. So our C value, our maximum is 9. That was in the question. Our amplitude is 4. So our C value is at a 5. So I can put, let's put a 5 here. The question didn't ask me to graph it, so I'm not too worried about having a beautiful graph here. This sketch is just to help me. I'm just going to put an equation of the axis here at 5. So we've got the amplitude and the C value, and we also know the period. Period is 120. So that means I'm just going to put 120 right here, 120. So that means because of symmetry, if I had a maximum at 0, I'm going to have another maximum at 120. That's one, I got to fit one cycle in between those 2 blue dots because I know the period is 120. So what's the minimum going to be? What's the lowest value going to be? The minimum will be 4 units below 5, so the minimum will be at 1. And I'm going to have a minimum value, so where will my graph be at a minimum? Right about here, right? It's exactly halfway between the 2 maximums is a minimum. So halfway between 0 and 120 is 60. So I'm going to put a 60 here, and I'm going to put a dot right there. I don't need to graph it. I don't need to be doing all this, but it's really going to help me to come up with an equation. So that's good enough. Let's put a wave in here. Whoops. That's not a great wave. Fix that. Well, I'm not being marked for my wave, so it doesn't really matter. So there's one cycle. Now we have to come up with an equation. Cos is always easier. If the question doesn't tell you that you have to use sine or cos, use cos. Use cos. Cos is easiest because, remember our parent function for cos, let me put it down here. I'll draw a little sketch. Okay, I'm going to start at 1 and I've got to get a maximum. I'm drawing cos, so there's a maximum at 1. There's a maximum at 360, there's a maximum at negative 360, so there's a minimum halfway between. So here's my parent graph of cos. Okay. So looking at this cos wave, remember, it's on the y-axis. Think of the y-axis kind of as your starting place. We're not going to worry too much about the negative stuff. Imagine the graph starting here. So it starts on the y-axis. Its y-intercept is a maximum. This y-intercept is also a maximum. It told us that in the question. The maximum is at 0,9. So we also have a y-intercept at a maximum here. So that means I'm going to use cos as my parent function, and then I won't need to worry about this d value. As long as I still have a maximum on the y-axis or a minimum, and then I could make my a value negative, then I don't need to worry about the d value, because the d value is a hard one. So let me write an equation here with everything we've got. We've got f at x equals, so the first thing is a. I'm keeping that a positive 4. I'm not changing my amplitude to a negative a value. Then I'm going to choose between sine or cos, and I'm picking cos. Next is k value. Oh, we didn't do the k value yet, did we? K value. So k value k is 360 divided by the period. The period they told us was 120. So our k value is a 3. So 3 goes in for k, x minus our d value is a 0, and our c value is a 5. Or making that look a little more presentable, we have 4 cos 3x plus 5. That's one equation. There's an infinite number to write equations. I could have also, so I'm going to talk a little bit about the d value here. I could have also used this maximum and said this is actually this point here. So I took this maximum right here at 0. My cos wave has a maximum when my x-axis is 0. And I could say, well, that's this one. It got pushed over 120 degrees. So here is my d value. This point was supposed to be here, and it got pushed over. So if I want to think about it like that, if I want to think that this point here was my original maximum that was on my cosine wave, it got pushed over to that spot, that would mean I would have a d value of 120 because my maximum is over there now. So I could write, I'll put it below here. I could also have put f at x equals, everything else is the same, but this time x minus 120, there's a d value, plus 5. So could have done that equation too, and there are an infinite number of ways to write equations. But you want to keep it simple, of course. If you have a maximum already on the y-axis, then just use a d value of 0. Example 4. This is our last one. The graph shown has the following partial equation. So this time I did all the other stuff for you because we've done lots of practice with the a, the k, and the c already. Determine 2 equations using sine and 2 equations using cosine. Begin by drawing one of the parent graphs on the grid at a time. We're going to do cos first because cos is easiest. So we have everything except the d value. Let me put the cos wave on here. So remember the cos wave on the y-axis starts at a y value of 1. And I can't even fit the next maximum, which would be at 360. But it does have a minimum at 180 of -1 and crosses through at 90. So I can get a few things here. Get a few dots at 270. Let's say 270 is right there. So I can get a partial cos wave on here. And in the other direction, let's just come through here. So that's our parent graph, cos x. And clearly the black graph does not match it. Right? The black graph has been horizontally compressed. It's been squeezed in. I got a lot more cycles in here than I have in the parent. It's way down, it's down lower, and it's taller. This one isn't very tall at all compared to this one. So we've got a lot of changes to talk about, but most of them are already here. The amplitude is a 2 of this black one. -4 is where we would draw in that, the equation of the axis there. There's a -4. That's where the c value comes from. The amplitude is here. That's 2 units. And the period is, they've already given us the k value. Remember, the period comes from one maximum. So we have a maximum at 30, and we have another maximum at 150. So my period is 120, so my k value is 3. Okay, so all that's already done for us. We just need to come up with the d value. The parent function of cos has a y-intercept at a maximum. This one's y-intercept is not at a maximum. But my maximum is here. So what I'm going to say has happened, I've had all these other transformations, the 3, the -4, all these other things have happened, and this maximum has been pushed over to 30. So my maximum is now, well, it's down here, but my maximum has been pushed over 30 units. That's where the maximum is now. So the cosine graph had a maximum on the y-axis. This one doesn't. It's been pushed over 30 units. So I would have a d value of 30. I could also take this d value here at 150. I could also say, oh no, it's actually been pushed over 150 units. That's how I'm going to get two. That's how I can get two equations out of this. I could also take this d value right here. Say, no, my d value is actually a negative 90 because it's been pushed 90 units to the left. So you pick any maximum to come up with a cosine equation, and you use that for your d value. That's it. 2 cos 3. So I'm going to use the first one. Usually we use the first one. X, it's a positive 30, but remember there's already a negative sign there. So it's actually negative 30 when I put the plus 30 in. Minus 4. So to come up with the equation of a cosine graph, you just pick the first maximum. And in this case, we have to do 2 equations with cosine. So I'm going to pick, I could pick any of the other maxims that I want to. I'll do the negative one just to be different here. 2 cos 3 x, that because there's already a minus sign in the brackets and I'm putting in a negative 90, it's going to become a plus 90. Minus 4. I'm going to do one more. So I want to talk about a minimum. Let's talk about this first minimum down here. This is a minimum. If I wanted to, I could use that as my d value. That's a d value of, what's that value there? That's a d value of 90. Okay, so my d value is 90. But then I need a negative a value because I'm talking about a minimum now. So I could also say f at x equals negative 2 cos 3x minus 90 minus 4. And you could type all of these into decimals and you just keep getting a graph lining right on top of the other. You would get this black graph over and over and over again with any of these equations. Usually we want to keep it simple. We're going to pick the first maximum value for our d value. Okay, now we're going to do sine, and sine can be a little harder. It's really easy to locate a maximum. It's a little harder to locate that same value for sine. So the first thing I'm going to do is erase this cos graph here because I'm going to put sine on here. So I'm going to erase all of this stuff. Now I'm going to put sine on in red, and sine passes, the parent function passes right through the origin, 0, 0. And then every 90 degrees, something important is happening. It's either a maximum or a minimum or an intercept with the equation of the axis. So let's get a few things on here and draw in the parent function for sine. Okay, there's y equals sine x. So again, we're going to look at that all-important y-intercept. The y-intercept on the sine wave is at 0. It's not at a maximum. It's at a halfway spot, right? It's like this number here. It's halfway, and it's actually where the sine wave intersects the equation of the axis. So the y-intercept of the parent function is when the graph crosses the equation of the axis. So let's look at our graph below. Where does it cross the equation of the axis? It crosses here, 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 lots of places, here, here, here. There are many places where it crosses the equation of the axis. But the thing that makes it a little more challenging for sine is that I have to make sure it's the point where it's crossing the equation of the axis and the wave is going up, not coming down, because that's how we graph sine. It starts at 0 and then it increases up to 90. So I need to find the places on this graph where my equation of the axis and graph intersect. So there's all these that I'm circling in blue. These are all places where the equation of the axis and the graph intersect, but the graph has to be going up at that point. So it's going up here, down the next one. Up here, the next one's down, so that's not good. We don't want that one. This one is going up, the next one's going down, and this one's going up. So our D value we have to find this spot. We have to find where the graph crosses the equation of the axis and it's going up. So I've got 3 here, 4 here. Actually, I could use any of these 4. Let me just put them in a brighter color here. This is one spot. All of these purple boxes indicate places where my sine wave is crossing the equation of the axis and increasing. Why wouldn't I take the easiest one, which is the one directly below it? That's the easiest one to take. That would give me a D value of 0, because that just shows that the sine wave has just dropped down, but it hasn't moved side to side. But because I have to pick 2, in my second one, I'm going to take this value here of 120, and I'm going to say that this point, my y-intercept, got pushed over 120 units. So my graph, my equations are f of x equals 2 sine this time, 3. The first one I picked was a 0. Minus 4, which we know we can rewrite a little cleaner with 3x minus 4. We need a second equation, so I'm just going to pick the next one. 2 sine 3 x minus 120 minus 4. So I only needed 2. I can stop there, but I am going to show you a negative one as well. What happens if I did pick this one right here? So this one would have a D value of 60, but the graph is going down. It's not going up. So I would need a negative A value to reflect that. So I could write f of x equals negative 2 sine 3 x minus 60 minus 4. So look at all of the different ways, and I could go on all day. I could keep making more and more and more. All the different ways just to write this equation for this one black wave. So what if your answer doesn't match the back of the book? Because they're not going to put them all down wherever you're looking up your solutions. So install the Desmos app on your phone, or just go to the website. That's what I do. Type in your equation. So whatever one of these you got, type it in. And then type the answer that was in the back of the book. They should give you the same graph. They should line up one right on top of the other. You don't have to have the answer they have in the back. When I mark a test, I am prepared to mark all kinds of different possibilities here. Usually people pick, if it's cosine, they pick the first maximum. If it's sine, they'll pick the first case where we have that point of intersection going up. Usually that's what it is. But you don't have to, and often you're asked for 2 equations, or one with sine and one with cosine, so this is how you can check. This is a really important lesson for understanding how to graph sine, how to come up with equations for sine and cosine, so I do recommend as you do your homework that you rewatch some of the examples again.